this question from Div 3 of Code Forces round 938. So you can quickly read this question. So I'll just simply give a summary of this. So you are given n ships and each ship has some durability. So for example, A is the durability, and there are four ships. So the first ship has the durability as 1, the second has as 2, third as 4th, and the last one as 3. So and K is the attacks, possible attacks on the ship, but with the following condition such that it attacks the first ship, then the last, and then the first again, and so on, right? So if you look at this example, so it's given initially it's 1 2 3 1 2 4 and 3. So after the first attack, this one is completely destroyed, and we are remaining with these three ships. And the second attack consecutively, you can see as the left position, as it was attacked on the left position of the array. So now the next, in the next attack, it will attack on the rightmost position, so it get reduced by 2, right? And in the consecutive step, it will be attacked on the first position and then again in the last position, and so on. After the fifth attack, the remaining ships will be these two with the given durabilities, right? So if you think closely this problem statement, so there are two things that we need to take into consideration. So at first, we have to decide, like it's sure that we'll be starting from the first index, the rightmost part of the array, and then move to the left, the right, we'll start from the leftmost. We'll start from the, so basically if this is our array, so we're starting from the left and to the right. Okay, so this continuous movement, we'll think it in this way. If we, is there any way if we can do it in a single operation? So what we can do here is, so we can take this to action as a single step, right? So what we can do is we can take the minimum of the a of L comma a of R, right? So this minimum will be some value m. Now we'll check if our k is greater than equals to 2 into m. So what does this mean is, like, in, so the minimum value, we know the minimum value will be removed, right? So we'll do that operation in the single step. And what happens if k is less than 2 into m? So what happens in this case? So now we know the number of attacks remaining is less than my given required attack. So in this case, as we already know, we are always starting from the first position, that is the left position. So what we can do is, the number of attack here will be k by 2, as now the k is remaining, right, and it's less than m, so it can't completely remove the minimum ship, that is minimum durable ship that is present, but we have to just subtract it for our own sake, right? So this is k by 2, and the rightmost will also face a attack k by 2. Now what if the k is odd? K is odd. In that case, we know, we're sure of that this attack will be taken by the first leftmost, that is the leftmost ship itself. So we'll also add this k modulus 2, that is the remainder. All right, so this is basically the problem statement and its solution. So why I found this question to be interesting is, like, we can implement this using array, but there is another data structure that we can use here, and that is the DQ data structure. Okay, so the property of DQ we'll shortly understand. So suppose this is our DQ data structure, so we can be able to directly access this leftmost and the rightmost cell, and we can perform the operations such as we can fetch the value, as well as we can remove this completely from a given DQ, right? And also similarly for the rightmost. Okay, so let us quickly see the solution. Okay, so very first, we are taking the input n. N is basically our size of the array. N is basically the given size, right? So n equal to size, that is given, and k is basically the attacks, right? Now we are declaring DQ. This is standard C++ code, and this is uh, this is inbuilt function of dq that is given to us. And now we'll run a loop, for loop, right, to take the input as the value. So we'll see the test cases. So this c is the number of test cases, 4 is our n, and 5 is the k, and here is our input. So this is the following format, right? So this is what we're doing here. We're just simply inserting the values into our dq. So now the interesting part here is we'll keep a check on dq size is greater than 1. So again, like the dq size can be even or odd, right? It can be even or odd. So what does this mean? So we'll whatever logic we thought of, we are considering this for the even values only, even values of dq, right? So if the dq size is greater than 1 and there exists some value of k, that k should not be 0, right? K should not be 0. So we, just as we mentioned, we are finding the min of the dq front. The dq dot front is basically how we access the front element, and dq dot back is how we access the last element. So we'll find if k is greater than equals to 2 into minimum of these two. So we are just simply subtracting from the front and the last as well. Now you may ask, like how we know that, how we are going to delete it, how we are going to remove the ship. So this operation is done over here, right? We'll come back to that. Now what happens if k is less than 2 into m? So if the k is less than 2 into m, so just as we mentioned, we'll divide k by 2, as this attack needs to be divided, right, at this between the leftmost and the rightmost ship present. And if by any chance this is odd, so we are going that extra value to the front, as like that's obvious, right? So we are starting, this is the logic why you are starting off from the front, from the leftmost part of the array, which is our dq, right? So and similarly this one, and then we initialize k to 0, as there are no more attacks remaining, right? So clearly we are going to keep a check if dq while in each iteration we are going to check if dq front is 0, we are going to dq dot front. If the back is 0, dq dot pop back. This pop front is basically to remove this front part, and pop back is basically to remove this one. All right. So now the last most condition. So we mentioned, right, this while loop runs if taken into the fact that our dq size is even. So what if the dq size is 1 now, and this has been taken care of? So the this condition, if you check closely, it's greater than 1. So dq size can be at max 2. The moment it becomes 1, so it won't enter this while loop, right? So we have to check here if dq size exists and k is greater than dq dot front. So there is only one element remaining in this part, and we have to check if k is greater than this durability of the ship that is present. So we clearly dq dot pop front, we remove it, right, as it is the only ship that is going to attack. So there is no left and right scenario here, and simply our answer will be, answer is given the size, the beginning, the size of the array. I mean, you can consider any data structure like array or dq, and minus the remaining size, right? So what makes this question very interesting is if you try to solve this question with the array, and we can see the number of lines is significantly reduced when we use dq. Okay, so this becomes a very interesting question to solve for 1300 rating on Codeforces, and I found it very intuitive and a good question. So that's the reason I'm bringing it up here. Thank you very much. I hope you like this explanation, and yeah, thank you.